everyone, in this lesson we will study the instruction set. First, we need to understand what an instruction is. An instruction is a command that controls computer to perform a specified operation and can be recognized by the computer. In other words, it is a command issued by humans to the computer to execute a certain operation. The assembly instructions we will learn are instructions that represent binary codes recognizable by the computer in the form of mnemonics. Mnemonics are symbols that help humans memorize. Therefore, assembly instructions are programming languages designed purely to facilitate code writing and reading for humans, such as INT21H. Programmers have developed compilers that can translate assembly language into binary code for the computer to execute. As you have all learned C language, assembly language differs from C language. C language is a high-level language, while assembly language is a low-level language. The terms high-level and low-level here are defined relative to hardware. Since assembly language is closer to hardware processing, it is a low-level language. C language, being closer to human thinking and needs, is a high-level language. Learning assembly language helps you better understand the processing performed by computer hardware. The instruction set is a system composed of all instructions of the CPU and their usage rules. We will study the 8086 instruction set, including a series of instructions and their usage rules. Now, let's look at the basic composition of an instruction. An assembly language instruction consists of an opcode and an operands. Here, placing the operand in square brackets means that the operand may or may not exist. In other words, an instruction may have one operand, two operands, or no operands, depending on the specific instruction usage rules. The opcode indicates what operation we want the computer to perform. For example, whether you wanted to transfer data or perform arithmetic operations is reflected in the opcode. Generally, the opcode is represented by three uppercase letters, usually abbreviations of the corresponding English words. For example, the data transfer instruction is represented by MOV, the first three letters of move, and the addition instruction by a DD, the first three letters of addition, which facilitates memorization and use. When there are two operands in an instruction, they are separated by a comma, indicating the objects on which the operation is performed. For example, for an addition operation, we need to specify the addend and the adjunct. ADD is followed by two operands, which are the addend and the adjunct. However, the meaning of the operands differs depending on their positions. The operand closer to the opcode is the destination operand. It can be both the source of the operation and the destination to store the result after the operation. The operand after the comma is the source operand. It only represents the source of the operand, not the destination. The source operand can be any number or value accessible by the CPU. But the destination operand must be a location that can store data since it holds the operation result, or it cannot be used as a destination operand. Operands are mainly divided into three categories. The first category is the immediate operand, which is essentially a constant. Constants in instructions are generally in decimal or hexadecimal. For decimal numbers, no suffix is required. For hexadecimal numbers, use an uppercase H as the suffix. If a hexadecimal number starts with a letter, a leading zero must be added. As part of the operand, the immediate operand can only be placed in the source operand position, not the destination operand position, because it represents a constant rather than a data storage space, making it unsuitable as a destination operand. Second, the immediate operand does not change due to instruction execution, because it is a constant invariable. Now that we understand its usage rules, let's look at the following two instructions. The first one is move AX3 ACFH. In this instruction, 3 ACFH is clearly a constant, that is, the immediate operand we mentioned. Placing it in the position of the source operand makes this instruction correct. The second instruction places the immediate operand 3 ACFH in the position of the destination operand. As we stated, an immediate operand cannot be used as a destination operand. So the second instruction is incorrect. Next, let's look at the second type of operand, the register operand. Register operands are the registers we learned about earlier. We have studied a total of 14 registers, and except for IP and FR, the remaining 12 registers can all be used as operands. These 12 register operands include 8 general purpose registers and 4 segment registers. Since register operands are storage spaces capable of holding data, they can be used as both source operands and destination operands. The instruction pointer, IP, is modified by the operating system itself and is not available for programmer to use, so it cannot be used as an operand. The flag register, FR, is not a typical 16-bit data storage space. It stores and modifies data by bit, making it special and unsuitable as an operand. The last type of operand is the memory operand. Memory operands are placed in square brackets, representing values in memory space. Since it is an operand placed in memory space, it naturally serves as a storage space for data. Therefore, memory operands can function as both source operands and destination operands. However, please note that typically, a memory operand cannot simultaneously serve as both the source and destination operands. In other words, we cannot place square brackets in both the source and destination operand positions at the same time. This exception applies only to string operations, where both the source and destination operands can be memory operands. In all other cases, this is not allowed. To correctly locate the memory unit, we need to determine which segment the operand is in, that is, first determine its segment register. If the instruction does not specify a segment register, we use the CPU's default segment registers. That's all for this lesson. In the next lesson, we will study the addressing modes of operands. See you next time.